All right, let's go ahead and continue our problem. So notice before we were looking at this idea. Oh, let me get the camera. Sorry. We're looking at this idea that the conservation of energy could tell me the velocity of the projectile at this point shooting off. So if I go ahead and just look for my velocity in relation to the formula here with the drop of height, I'm going to notice that I've got my v squared is going to be equal to 2g difference of height. And I can solve that out with 2 times 10. We got 2.2, okay, minus 1, right? And that gives me a velocity as I shoot off right there that I can go ahead and then plug into my equation, okay? And that velocity, by the way, was 4.9 meters per second. And so it's kind of like saying that it's shooting off at 4.9 meters per second right there. But when I want to figure out the height that the projectile is going to launch at, it's not going to be based on this angled velocity. That's just going off at an angle. I need to make it based on just the height vertical y part of that velocity, or v sine of theta. Okay. Now, in order to figure out the height, and I don't have a time in this equation, I'm actually going to use the kinematics formula that we call the timeless equation, which just says that v squared equals u squared plus 2g delta y. That's 2ad, acceleration times d. Now, I notice that the final height is going to be 0 when I get to the top, but my initial height is actually going to be u sine of theta, okay? And I'm going to square that. And I'm going to do it plus 2g delta y. And when I go to my answer down here, delta y equals VO sine of theta squared divided by 2g. And when you put that math together, that actually equals 0.49 meters. But considering that we're already at a meter, I'm going to add it to the 1 meter. And that's actually 1.49 meters, which is my final answer. Okay. All right. Now, my last question says, the car is released from rest at point. Determine the minimum speed to be required so that the car can go around the loop right there. Now, I notice at this point, if it was going to be any slower, it's going to fall off of here. Okay. Now, that means that this normal force equals 0. So in this case, I go back to this equation here that I've used before, and I'm going to say mv squared over r equals normal plus mg. Okay. But in this case, the normal now is going to be 0. And then when I do that, I can go ahead and cancel my masses. And if I want to know the minimum speed, it's just going to be v equals the square root of rg. Okay, so real simple, and that's just 0.8 times 10, which equals 2.8 meters per second. Okay, and that's my final answer. And hopefully this thing can focus correctly, and then we'll be good. Okay, so given that this thing is being a little pain, let's see if I can get a little bit better of a focus on there for you right now. There's our final picture. I will go ahead and also put a picture of this on the website for you too, so you can see the worked out final answer there. All right, well, have a great day, guys.